moments later.
Where's my phone? Jovi, did you took my phone?
No, I was here all the time, but I did not take your phone.
Angelica, did you took my phone?
No, I did not took your phone. I left right after you left the room a while ago. So I'm sure I did not took your phone.
Then who took my phone?
In our daily lives, we often make conclusions. We connect ideas, analyze situations, and determine whether a statement is true or valid. And this process of arriving at logical conclusion is called reasoning. And in mathematics, we use specific patterns of reasoning. And that will be our topic for today. Rules of inference.
What rules of inference? Rules of inference help us determine valid conclusions from a given statements or premises. They are important in mathematics, proofs, logics, and problem solving as they get us to think systematically and critically. So in this video, we will learn about different rules of inference, their symbolic forms, and how they are applied in real-life situations and mathematical reasoning. So let us begin our discussion about rules of inference.
And our first rule of inference is modus ponens. Modus ponens is one of the old and the most fundamental rules of inference in logic. Its structures has two premises and one conclusion, and Hobbes' pattern. P, then Q, and P, therefore Q. For example, suppose we have this statement. Premise 1. If Angelica will study hard, then she will pass the exam. Premise 2. If Angelica will study hard, therefore we can conclude that Angelica will pass the exam. Do you understand? Very good. And for those who didn't, we will have another example. Example number 2. Following the same pattern. P, then Q, and P, therefore Q. If a triangle has three equal sides, then it is equilateral, and that is our premise 1. Premise number 2. If a triangle has three equal sides, therefore we can conclude that the triangle is equilateral. So by that examples, it proves that rules of inference, specifically modus ponens, exist in our everyday life.
Are you excited to know the second rules of inference? That's good. Now we have the modus tollens. It is a valid form of deductive argument, also known as denying the consequent. So it goes like this. If we have a statement that says P, then Q, and we know that Q is not true, therefore we can conclude that P is also not true. Now let's have an example. Suppose we have a statement. For the premise 1, we have if it is raining, then the ground is wet. For the premise 2, the ground is not wet. Therefore, we can conclude that yes, it is not raining. Now let's have another example. Suppose we have a statement. Premise 1. If Angelica is a lawyer, then she will be able to help us. Premise 2. She will not be able to help us. Therefore, we can conclude that Angelica is not a lawyer. Do you understand? That's good. Now that's how the modus tollens works.
The next rule of inference raises the question, what if we have to use two conditional statements to form a new conclusion? Hypothetical syllogism is the answer. So what is hypothetical syllogism? Hypothetical syllogism help us connect two conditional statements to form a new conclusion. So the pattern will be, if P leads to Q and Q leads to R, therefore P leads to R. Now, let's have an example. Suppose we have two conditional statements as our premises. First premise, if it rains, then the street become wet. The second premise, if the street become wet, then traffic becomes heavy. So, using hypothetical syllogism, what can we conclude? Now, let's identify what is our P, what is our Q, and what is our R. So what is our P? Our P is, it rains. And our Q, the street become wet. And our R, traffic becomes heavy. So we are given P, then Q, and Q, then R. So we can conclude that if it rains, then traffic becomes heavy. That is the result of hypothetical syllogism. Now, let's have another example. These are our premises. First premise, if I study hard, then I will pass the exam. The second premise, if I pass the exam, then I will graduate. So what is the logical conclusion? And now, let's identify what is our P, our Q, and our R. So what is our P? Our P is, I study hard. And our Q, I pass the exam. And our R, I graduate. So we are given P, then R, P, then Q, and Q, then R. So therefore, we can conclude that if I study hard, then I will graduate. So that is how hypothetical syllogism work. So I hope these examples help you to understand more clearly what is hypothetical syllogism is all about.
And now, we will proceed to disjunctive syllogism. It is a rule of reasoning that helps us choose between two possibilities. This follows two patterns. First, either P or Q is true, not Q is true, therefore P is true. Second pattern, either P or Q is true, not P is true, therefore Q is true. Just imagine that you only have two choices. If one choice is proven false, therefore the other choice must be true. That is the basic idea of disjunctive syllogism. For example, we let P will be the teacher is in the classroom and Q will be the teacher is in the office. We know that P or Q will be the teacher is in the classroom or in the office. So the not P here is the teacher is not in the classroom. Therefore, the teacher is in the office. Did you follow? Very good. And for the second example, we have either I will eat an apple or I will eat a banana. I will not eat a banana. Therefore, I will eat an apple. Did you understand? Very good. So in logic, or usually means at least one of the statement is true. If one option is false, the remaining option must be true.
And now, we will proceed to the conjunctions rule of inference. It is the most demanding as it requires both P and Q to be independently established before you can join them. You cannot assume either part or both must already appear as a proven line in your argument. And we have this pattern. Premise 1, P. Premise 2, the Q. And the conclusion is P and Q. For example, suppose we have this statement. Premise 1. It is Monday. Premise 2. The store is open. Therefore, our conclusion is it is Monday and the store is open. Easy? Did you get it? Very good. And we'll have another example. Premise 1. Square have 4 equal sides. Premise 2. Square have 4 right angles. Another conclusion is very good. Square have 4 equal sides and 4 right angles. Basic? Very good. And we will proceed to another rules of inference.
So our next rule of inference is called addition. So what is addition? Addition requires only one true premise and let you attach any other proposition. So the new proposition is unconstrained. So what does it mean? It doesn't need to be known, proven, or even plausible. So this rule is valid because disjunction only requires one true disjunct. The pattern here will be, we will have one premise and the conclusion is the disjunction of the P, our premise, and another premise, our Q. So let's have an example. Our example will be, we will have our premise, it is sunny today. So what will be our conclusion? So we will add one premise, any other proposition. So let's assume our Q will be, I brought an umbrella. So our conclusion will be, it is sunny today, or I brought an umbrella. So did you understand? If you understand, that is very good. But if you don't, let's have another example. Our next example. Our premise is, Jovi passed the exam. So what will be our conclusion? Now, let's add another premise or another proposition. So let's assume that our next proposition is, she studied all night. So our conclusion will be, Jovi passed the exam, or she studied all night. So that is how the rule of inference addition works. So did you understand? Give us a thumbs up if you understand the addition rule of inference.
Now let's move on to the next rules of inference, and that is called simplification. This means that when you know a compound statement joined by and is true, therefore, we can conclude that each part is also true. So in symbolic form, we have P and Q, therefore B. Also, P and Q, therefore Q. Now let's have an example. Suppose we have a statement, the computer is on and the internet is working. So using simplification, we can conclude that the computer is on, and we can also conclude that the internet is working. So do you understand? That's good. Now let's have another example. Example number 2. Suppose we have a statement, I am studying for my exam and I am taking notes. So using simplification, we can conclude that I am studying for my exam, and we can also conclude that I am taking notes. So that's how simplification works.
And that wraps up our video tutorial about rules of inference. Throughout this lesson, we have learned how logical arguments are formed using different rules, such as modus tollens, disjunctive syllogism, hypothetical syllogism, addition, conjunction, and simplification. These rules play an important role in mathematics, logic, and problem solving because they help us arrive at valid conclusions from given statements. And by understanding and applying these rules correctly, we can strengthen our reasoning and analytical thinking skills.
We hope this video tutorial helped you better understand the concepts and applications of the rules of inference. Continue to practice different examples for better understanding and for to improve your logical reasoning.
Thank you for watching. We hope to see you to another video tutorial. Have a good day ahead.
Bye!